How's the day? How's the weekend? So let's start with today's LeetCode problem, that is 2492, minimum score of a path between two cities. Okay. What the problem statement says, we are given a positive integer n representing n cities from 1 to n. Okay, we have n cities 1 to n, and we have given in 2D array roads. The roads of I represent ai, bi, and distance of I. Okay, let's say city A, city B, and engagement distance. Okay, the road is bidirectional, means it's not a directed graph, it's a directional and directed graph. If this is valid, then this is also valid. Okay. The score of a path between two cities defined as the minimum distance of a road in this one. Okay, so if there is a path between C to D, what will be score? So score will be minimum of all these three. Minimum of D1, D2, D3. Okay. Now, we have to return the minimum possible score. So out of, if let's say there are 5 valid paths, right? And each have a score of score 1, score 2, score 3, and so on. So answer will be minimum of all of SIs, right? Whatever the score. Now, okay, now path is a sequence of roads between two cities. Okay, it is allowed for a path to contain same road multiple times. So it means we can visit the same road multiple times. Okay, and we can visit one and end multiple times as well. So what does this mean? This is important. Okay, so initially we see, right, we apply the Dijkstra, then we sort it based on the right DIs. We apply a min hub, and when we reach n minus n node, we give it the answer. But that will not work here, right? Dijkstras. That will not work. And why it will not work? This is because of this line. This line, what does it say? Read about it. We can visit the same road again and again. Means, let's say I have a city from 1, 2, 3, and this is 4, say this is 5, and I have to go from 1 to 3. Okay. Now, I have to go from 1 to 5, right? 1 to n basically. And we have given, right, 3, say let's say 2, let's say 5, let's say 1. Then according to Dijkstra's, what we will get is this path, right? So our answer will be 2, but that is wrong. Since we can visit the same road again and again, what we are going to do here is we come here, we come from 3 to 4, right? Then we come back to 3 and then we go to 5. It means we visited this one as well, right? So our answer will be 1. Now, so what do we get from this? It means each road which is connected, right? Every connected road we can visit. Every connected road we can visit. So it means out of all connected roads, right? Out of all connected roads, we have to find the minimum distance value. Okay, now, so what is the approach now? One is, right, kind of every time we see there is a connected component, what comes to our mind? Disjoint sets. Disjoint sets or union find, it's known by various names. Another approach what we can take is BFS. Why? So let's say we initialize our queue with initial node 1, right? Then we push all its connected nodes to the queue, let's say x1, x2. And now, right, we don't mark them visited right now. So when we pop them from the queue, let's say when I pop, right, when we pop or remove from the queue, remove x1, I mark visited of x1 equals to true. Then I traverse all the roads which are possible from x1, right? So let's say this is 1, this is 2, this is 3, let's take our above example. Right, 3, 4, this is 5. We have to go from 1 to 5, right? Initially 1 pushes 2 to the queue, 2 pushes 3 to the queue. Now, when we come to 3, what we are going to do is, right, when we are on 3, so we every, right, 3 to 4 and 3 to 5, both of these we push to the queue. We push 4, we push queue. Now, what we do? So, when I remove 3, I mark visited of 3, right? True. And since I traverse this edge now, right? So, I have this one distance as well. But when I come back from again 4 to 3, I will not go on this because we have already taken care of this road. So that is the approach for BFS. So let's solve by BFS because it's more intuitive. Union find is sometimes hard to know. If you know union find. If you don't know, it will be difficult to implement. But BFS we generally know if we know the graph. So this is the approach that we're going to take in the loop. We initially prepare our adjacency list. We initialize a visited of size n plus 1, right? In the queue, we push 1 as an initial node. Now, while our queue node size greater than 0, right? So what do? We remove the top node, right? So let's say top we get some x and we get only x. We only need, right? We only need the next node top. We remove it and we mark visited of x equals to true. And what do? We loop over, right? Adjacency list of x, right? We loop over all edges, right? We loop over all edges that are possible from x. Then what do? Right? From adjacency list, we get our next node, right? We got our next node, and what do we get? Along with next, we get the di. Because when we create the adjacency list, we create a pair basically. So in pair, we push the name vi and di from any ui. This is what we're going to push there. Now what we'll do, right? If it's not visited, right? If it's not visited, then what are we going to do? Then we take, right? Then we take our answer equals to minimum of what? Answer comma di, right? And what are we going to do? We add this annex to the queue. So this is the answer, right? Whenever queue is empty, we return. It's pretty straightforward. So what will be the time complexity, right? The number of edges, right? So n plus time, basically. So yeah, that's it. Now let's see the code part. We are going to solve in Java because I'm transitioning from C++. So let's see the implementation part. Let's create a pair first because we are going to use it, right? So we can also use a record as well. So I'm just comfortable using a pair. So we'll do, right? We initialize the default class. What we do, when we pass, what will do this dot, right? This dot b plus what b, this dot d plus what d, right? Our first, what will be the first is to prepare the adjacency list. So let's say it will be pair adjacency list, right? First array list, we have to initialize it, right? So now we do less than equals to n because nodes are from 1 to n. We do plus, right? We add, right? For each position, we add a new array list to it. Then what we are going to do, once we have the array list, next we need a queue. So queue is an interface. Then queue equals to, right? We will use a array dequeue. Standard one is fine because we only want to remove the elements, right? Now we also need one visited. Boolean one visited, right? What's it going to do is new Boolean and plus one, right? Now what we are going to do, right? While our queue road size, right? We still have elements in queue, right? We want to traverse them and we need one answer as well. Let's say anti-answer equals to we initialize this to initially maximum. So what is the maximum value of road stored length is 25, right? So we'll say 1, right? So 1 greater than that, right? So what do? We remove, right? By integer, right? We remove the front element q road. A remove function that removes and gives us the front element. So we'll mark visited of front. It's true. And what do? We have to iterate over the adjacency list, right? For what? For say pair or what? Adjacency list dot get what? The current, right? Now what do? Yeah. So what do? We pair, right? And t next equals to what? Right? Pair distance equals to what? Pair dot d. This is pair dot. What I'm typing pair dot v. Okay, then we check if it's not visited, right? If not visited, of what? Next, right? Then what are we gonna do? We are update our answer. Answer equals to max dot minimum of what? Answer comma d. And what we are going to do, right? We are adding it to the queue. Queue dot add what is next. Now we are going to add to the queue. Once we have everything, we return the answer. Seems good. Let's see what happens. Okay, queue integer q equals to new cannot find symbol. Okay, this typo there, huh? DQ. Okay, so we get the maximum value only. Why? Because we haven't put the initial value 1 to the queue. right? Q rotate when we have to hit the initial one. Okay, so just making some silly mistakes. Okay, we did a Q rotate and Q remove one. Okay, we haven't added the roads and for aren't they right? Are in roads. What we are going to do at this MCLS dot, we are going to get what r of 0 and what we are going to add there, right? New pair what r of 1, r of 2. And since it's a bidirectional graph, we are going to do the reverse as well. New pair r of 0, r of 2. Okay, hope this works. Let's see. Okay, it works. Let's submit. Okay, so let's analyze the time complexity as well. So, so time complexity is of n plus m basically. It's same, but if you use a disjoint set, it will be mathematically better. Not the functionally, it will still be same. So you see, time complexity is of n plus e. That is fine.